how to productionize generative AI or machine learning solutions. As you can imagine, nowadays we have only 10 customers that they're trying to do that, so I'm here to give you all this knowledge. So what I have prepared for you is a journey, right? Based on your maturity, how you can start on the GenAI space, what are the tools that you can use on the cloud, on AWS, what are the key operations that you need to build. And actually, I try to keep it high level. We will scratch just the surface, and we can have other deep dive sessions if it is necessary. But let's start with this. In the previous sessions, we saw different use cases that we need to build around generative AI, right, for our businesses in order to improve efficiencies. This is around text generation, question and answer, summarization, other use cases around image classification or generation of images or audio. I'm not going to stuck into this because we have so many things to discuss. Some key definitions in order to be in the same page, all of us. AI is the way to make machines to operate like humans. Machine learning is a tool to implement AI. Deep learning is a subcategory of machine learning. And over there, we have generative AI. Generative AI, we use foundation models. What are the foundation models? Big deep learning models, let's say, that they have been trained in trillions of data. And a subcategory, and the most important for most of the customers, are the large language models, the LLMs. I'm giving you these definitions because later on we will use them. How do we build foundation models? As I said earlier, we use trillions of data. What type of data? It depends on the model that you want to build. If it is a text-to-text model, for example, I give text and I get text as an output, then we used to give to the model while we train it unstructured data, unlabeled data, pure text. And these models, they are able to predict what is the next most possible sentence or paragraph, let's say. Then we have other foundation models for text to image. Over there, we need to have labeled data with images and text. If I give this text, this image will come out, etc. Or we can have text to audio, text to video, text to whatever will come in this market. But the first thing that we need to understand is where we are. What GenAI user we are. We have three different categories. We have the providers, first of all. The providers are the ones that they build the foundation models. They know about machine learning end-to-end. They have an army of data labelers or editors in order to prepare the datasets. And they need also to deploy this model in order to be accessible by others. We have the fine-tuners. The fine-tuners are the ones that they are using the models from the providers. They know about machine learning because actually they need to retrain the model somehow, and they need to have the end-to-end life cycle of machine learning implemented on their end. And lastly, we have the consumers. Most of the customers, they are consumers, so it is around the 80%. The consumers are the ones that they are using the models that either the providers or the fine-tuners have produced, and they want to focus on the application. They don't care about machine learning at all. They care mostly about prompt engineering, about other aspects of generative AI, like selecting the right model, but they don't need to know about machine learning. We have seen also trends that we have providers that they used to become also fine-tuners. I have created a generic model, right? A foundational model is a generic model that can answer questions. But if I want a model that can answer financial questions, I need to tailor that. So providers might become also fine-tuners at some point. And we have seen also consumers to become fine-tuners. At some point, we heard already about RAG and prompt engineering and all these approaches. We will reach the limits of them. So the next step is to build our own model, to retrain our model, or to fine-tune this model in order to improve the performance of these models. So consumers might become also fine-tuners. About productionization. Providers and fine-tuners, they need to productionize machine learning models. That means that they need to know, they need to have a platform for ML operations, as we call it, or MLOps otherwise. Have you heard about MLOps in the past? Any hands? Perfect, really happy for this. Now, from the consumer side, it is different. It is not like I productionize a model, it is I productionize an application. The only difference, of course, is about prompt engineering and data. Data is very important, and we will see that in the next. So what I will do now, I will get all the different journeys of all these user types, and I will show you what we need to implement and how to move everything into production. Let's start with the consumers. That is the most common one. The entry level for the consumers is they need to use tools that they use generative AI, and they don't really want to care about selecting models, using models, calling LLMs, etc. They want, for example, a chatbot that I can give my data set and I can ask questions immediately. Or I want to have my Visual Studio Code write a query, could you create for me a function doing sorting or XYZ, and I want to produce the code for this. Or I want to have a way to be able to have my data, my visualization dashboards, and to write queries like, give me the average of my revenue for the last 10 months. And what will happen is something to generate this for me, without even having knowledge of generative AI. So this is the entry level. And for this entry level, in AWS, we have Amazon Q. Amazon Q is nothing else than our business expert, right? That helps our customers to create easily chatbots by providing access to the data with a very secure way. It is very easy to link that with Visual Studio Code, and you are able to generate code immediately. And it's very easy to link it immediately with QuickSight, that is our visualization dashboard technology, and you are able to produce visualization dashboards by writing text. But I'm not going to stuck into this, because I think we are more expert than this. And we need to move a little bit to the advanced consumers. Now I have played with all these chatbots, I have played with code generation, I say, okay, I'm ready to start using LLMs. What should I do? The first thing that I need to do is to select the right model. I need to evaluate the model based on my own data, and I need to give access to my end users to interact with this through a chatbot or other applications. The end users, they give inputs, they get outputs, they give their rating, and this rating helps me to improve continuously my system. Let's go step by step in all these processes. Select foundation model. In the market, we have more than 16,000 models, LLMs, right? I stopped counting them since last September, so this number is since last September. You can update that as you want. The first thing that we ask our customers to do is to create some kind of reference tables. What are these reference tables? These reference tables, they have the most important LLMs or foundation models, depending on your use cases, that you want to use in your business. So you need to do a first short listing, let's say, of the most important models out there. Then, for each use case that arrives, for example, I want to build a summarization use case. What I need to do is I need to select the top 3 models in order to evaluate if they can solve my problem. Now, out of these 3 models, I need now to run intensive evaluation. Why? Because it is really important to give back the right answers, right? But this evaluation gives me the precision. The answer to get the one model that I will use is not just the precision. We need to take into account cost, latency, or other parameters might be important for you. This will give us the one single model, the combination of all these metrics, in order to create a very robust solution. Let's start with examples for all of them. How do we create the reference table, first of all? We have foundation models that they have different capabilities. This is what we need to understand, the different capabilities that we need to check. First of all, is a model proprietary or open source? Does a model has commercial license? Even if you select an open source model, not all the open source models, they have commercial license. That means that you cannot use them into your products. Are those fine-tunables if I want to fine-tune a model? Yes or no? What about the speed? If I want to create a chatbot that I need millisecond latency, right? The model needs to be really fast. If I want to create a summarization model that runs in batches, then probably I don't care about the speed. Parameters, the number of parameters. The more parameters means most of the times, not always, that we will have better accuracy, for example. The next one is about context window. Context window is very important because if you want to generate, if you want, in RAG cases, that you need to pass a large number of data, right? And to get probably a large output as well. For example, I give all my financial documents and I get the summary. You need a large context window that might cause also more expensive LLM. But if I want to create a chatbot that I have just a very small inputs and outputs, I can use a smaller model with smaller context window and to have better cost. The next capability is about trained on, in what data this model has been trained on. If you go to use an LLM to generate code, and this LLM is not trained on code, then it will give you garbage, right? So you need to know that this model that you will choose has been trained on code. Then it's about quality, that I will show you what is that, and how we will calculate that. And lastly is about your experience, your skill, how familiar you are with a model. Here I have an example of a reference table that I created last June. Again, I have stopped updating that because the market changes continuously. One of the most important columns that I have here is the GPU instance, right? This tells you what is the machine that you need, the minimum machine that you need to deploy a model on the cloud. And this is a very good indicator for the cost. And most of the customers, they are checking about this. So here I have an example. This is an example of proprietary models. Here is an example of open source models. And one more example from Stanford. And this is this table here. So this table here also produced last year. Stanford University cares about EU AI Act, and they want to check all the different categories of EU AI Act against all the different models. So this is very important here in Europe. Okay, we have created now all the different reference tables. And a new use case arrives. For example, I want to have a summarization solution for our financial documents. How do we evaluate these models? The first, let's say, to select the top 3 models. Over there, we have the prompt engineers or GenAI developers. It might be exactly the same person, that they create the first 5 prompts. And trust me, 5 prompts are really enough from the 20 models to select which one is the best for your use case. So over there, we introduced the notion of prompt catalog. What is this prompt catalog? It is a place that we store our test prompts in order later on to extend that and to evaluate massively our model and our LLM. So with 5 prompts, the prompt engineers and GenAI developers, they are able to select the top 3 models for the particular use case. How do we evaluate now these models? We need data, right? Data. Do we have label data, actually? What is label data? If I give a financial document, do I have an example summary, how it looks like? Yes or no? If I have this example summary, then I can compare this example summary somehow. Or if I want to build a question and answer, a chatbot, right? Who is the Prime Minister of United Kingdom? And to give me Rishi Sunak, for example, I have one particular answer. But if I have this label data, I can produce metrics automatically without any manual operation. What type of metrics are we going to generate? If now I have a discrete answer, like the example that I gave you about the Prime Minister, we can use classic accuracy metrics, precision recall, F1 score, etc. If this is not the case, for example, in summarization, right? That is a task-specific metric that I need to use. In that case, I need to use similarity metrics. Is my example summary similar to the summary that an LLM produced for me? Yes or no? Other metrics there are related to toxicity, how toxic is an answer, functional knowledge, semantic robustness. It depends on the task that you have, and you might need more than one metrics in order to select the right model. But at the beginning of your journey, probably you don't have label data, and this is the biggest problem. How do I evaluate the model if I don't have evaluation data? Because to evaluate a model like this, you need some thousands of records. In that case, we need to ask a question. Do I want to automate the process? Is my solution quite critical? Is that fault tolerant? Yes or no? For most of the customers that the applications are not really fault tolerant, what we need to do first is human in the loop. What is human in the loop? We need to have humans to label the initial data set for us, right? And to give us all these examples. Or, for example, in the summarization problem, right? How do we evaluate that with humans? The LLM gives us the summary, and then a human needs to go and to say, oh, this summary was great because of X, Y, Z, I give 4 out of 5. This is the job of the human over there. But because sometimes this is not possible, right? And the human in the loop might be expensive because you need people to do that. Many customers, they are also looking for the approach to have another LLM evaluator in order to assess the output of the other LLMs. That means this LLM plays exactly the role of the human, right? It will generate a summary, what was wrong or what was good, and it will generate the metric that I said before, like 4 out of 5 stars. And more or less, this is the tree that we need to know about evaluation, and it will be very important later on for productionizing everything. Let me give you an example. Okay. Here I have this evaluation prompt catalog that I said earlier. Over there, it is the place that I store all of my prompts, right? With the inputs, even if it has prompt and context or whatever, and the specific outputs if I have labeled the data. So what we have is the prompt engineers, they create this extended first version. We have GenAI developers that they pass all this into the models. We might have also GenAI prompt testers to extend that. And the outcome is, for all the LLMs, we produce now an output, right? And we have the labeled output, the output of the LLMs, and we calculate the metrics that I said earlier, depending on our use case, if we can calculate the metrics. Otherwise, we get feedback from the user. To extend, of course, these tests, we need to have prompt testers into production. That means that we might need to have some kind of crowdsourcing. Before we move to production, I have seen customers building playgrounds for these testers. I have a customer that have built 60 different playgrounds for the use cases in order to make sure that everything works. And this, what will give me is an aggregated table with the results of all the foundation models that I wanted to test in terms of the accuracy of them. But as I said earlier, right, the selection of a model is not based on accuracy, not based on precision. You need also to consider cost and latency or speed. So how do we select the model? We need to set priorities. For example, here, my priority 0 is the cost, priority 1 is the precision, and I don't care about speed. I have the results that we have gathered since the last step or through the reference tables. And over there, we can see the foundation model 1 performs amazingly good, right? So 5 out of 5 stars. But it is also the most expensive one. Actually, I'm not going to select this because my priority is the cost. I'm going to select foundation model 2 that performs well, and it is has the lowest cost. So the answer for this one is foundation model 2. So the most the best model sometimes in terms of accuracy is not the right model based on your use cases or your needs and priorities. Okay, finally, we have selected the right model for the use case. What do we need to develop in order to bring that into production? First of all, we need to create a backend. What is this backend? We need to have the GenAI developers and prompt engineers. They have selected the foundation models, they have done already the prompt engineering, they have created the prompt catalog. What is next that we need to implement here? Most of the times, what we need to implement is chains of prompts or chains of applications. We need to filter input and outputs. We cannot send to this LLM all the inputs, right? If I have a chatbot for a bank, right? If I ask this chatbot who is the prime minister, immediately the system should return back and say, I cannot answer this question, without triggering the LLM. With that way, you can reduce massively the cost. Or from the other side, if an LLM responds back with a very toxic answer, I need to catch it, and I need to return back a right answer to the user. Otherwise, I might offend the user. And overall, what we need to build are the guardrails. This is the most important thing. Later today at 1, Sasha Rubel from our team, she has a talk about responsible AI. Probably it's very, very good to listen about this. So, guardrails. Guardrails might be topic-specific. I want to ignore all the requests for topics that I cannot cover. Might be removing PII data or catching toxic and harmful inputs and outputs. And we need also to build a rating mechanism in order to use that every time that we get inputs and outputs. We need somehow to store this interaction with LLM to be able to improve continuously our use case. And this is not enough. We need now a front end, right? We need a website. How are you going to interact with these models, the end users? So we have the app devs or DevOps, depending on your structure. And what they build are just websites that they give access to the end users to interact with LLM through a chatbot, through something else. And the end users, they use the chatbot, they send the rating, and this returns back to the test. So more or less, this is the end-to-end story and what we want to build. Initially, the customers, they used to build that with LangChain and Streamlit, but in my opinion, it is not production ready if you go towards that direction. Now, we have this, but we haven't touched a very important aspect. How do we implement RAG, Retrieval Augmented Documentation? Everybody here talks about RAG. It is not a simple job, right, to do. Normally, in a system, what we have up to this point is the end user that interacts with a large language model that is very generic and gets the responses. But if I go to this large language model that hasn't been trained in my data and ask a question, for example, based on my financial records of 2023, summarize the annual achievements, the model is not going to answer something that makes sense because they don't know my data. So this will fail. What we need to do is we need somehow to feed our data to the model. How can we feed this data to our model? Normally, what we have is this offline process here at the bottom, that we have a data lake that we store all of our data on the cloud. This might be different databases, S3, whatever you might have. But somehow we need to search. We need to say, okay, is this input that I give this question relevant to some of my data in my data lake? How can you do this similarity search, or how can you search for this information? The easiest way to do that is by creating vectors. Vectors is something that the machines, they really understand. But before you create these vectors, you need also to chunk the information. If I want to search and to give me answers to LLM based on paragraph by paragraph, you might need to split that, chunk the documents paragraph by paragraph. If you want to have just the documents, then you can have a bigger chunk. So chunking is the first piece, and then we pass all these chunks into the embedding models that they transform everything to vectors, and we store everything to our vector store, vector database, depending what you have. Now, let's link that with our LLM. How this works. What is happening is the input from the user goes to the same embedding model as the one that we use to vectorize our data and transforms this input into vectors. Then now we are able to do this similarity search. And what will happen is this will help us to get the context, as we call. What is a context? The context in my case here are all the financial records. I got them. What is the next step? We need to combine this input, the initial input, with this context, and to give this as an instruction to the LLM in order to give us precise results. As you can imagine, RAG is not an easy thing to do. We have the offline process of transforming their source data to vectors. In AWS, we say that all the databases and everything will be transformed to vectors at some point automatically. And we have the online process that someone asks a question, gets the right information, combine this, give that to the LLM, and present something that makes sense to the user. Now, to simplify everything, sorry for the pointer. Before we simplify everything. So we have some other advanced consumers that they say, okay, now I know how to implement RAG, I know how to use the right LLM. I want to fine-tune as well. But I want to fine-tune without having knowledge, by calling an API, right? So what they normally want to do is they want to create a storage on the cloud, upload their data over there, and trigger a fine-tuning that we will talk about this later, don't worry about this. And then to pass this fine-tuned model back to the selection process. Okay, how can we implement that? This sounds a little bit tricky, right? So what we need to do is we need to extend a little bit the front end. We need to add the capability of creating a user. By creating a user, actually, I create a storage on the cloud to upload the data, and somehow I need to have an API to call the fine-tuning. So this is the end-to-end story if you want to have all the different aspects. But it is still difficult to be implementing. And what we have is the definition, some definitions that I want to give you. DevOps is the way to productionize applications like websites by combining people, process, and technology. This is a very important aspect, right? It is not only about technology, but also people and processes. Now we have also the notion of GenAIOps. GenAIOps is to productionize generative AI applications. And of course, the key difference that we saw already are related to how we select a model, how we evaluate the model, about the guardrails, about data retrieval. These are all the additions that we need to have in the space. Now, in AWS, in order to help you to implement all this stuff, very, very simple way, we have Amazon Bedrock. What is Amazon Bedrock? Amazon Bedrock gives you access to the most important and best models in the market, foundation models in the market. By calling an API, you can interact with them. It gives you the capability to fine-tune some of these models like Llama 2 or Amazon Bedrock Titan. So you can have also fine-tuning capabilities based on an API. It allows you to do the retrieval augmented generation easily by providing two different tools, Bedrock agents and Bedrock knowledge bases. What are the knowledge bases? Actually, you say, my data are located here, is located here. My vector data store is this one, do the rest for me. And what it happens is it automatically does all the vectorization and everything and the search behind the scenes, so you don't need to worry about this. Agents are the ones that they know what application they need to call. So I really suggest to play with those. And because security, data privacy, and all these parameters are very important for us in Amazon, we have Amazon Bedrock guardrails. These are the guardrails to filter input-outputs, not give harmful information, be topic-specific, or remove PII data. All this comes out of the box with a call of an API only. And everything is very secure. We don't use your data is in your private cloud, and security is priority 0 for us. Now in Bedrock, one last thing. Here are the available models that we have. My favorite one is Llama 2, because I'm using also in the next section that we'll see. And we announced also recently that we will have Mistral, and you will be able to play with that. Mistral is a smaller model that you are a faster one with lower cost that you can play with. So as you can imagine, we have the top players in the market. But enough with that. We have done now the RAG, we have done the guardrails, we know how to do everything. Now we want to go deeper. We are ready to build our own model. We are ready to fine-tune the model, to customize the model, and to do more deeper things. We have a team with data scientists eager to jump into this domain. How do we fine-tune? And what is the journey of the fine-tuners? First of all, we need to label data. Label data is very, very important, right? You need to give examples in order to fine-tune. Sorry for the clicker. In order to fine-tune a model. What is fine-tuning? Fine-tuning is like training a model, and we will see in more details in the next few slides. And after we train the model, we need to deploy the model, and we need to act as consumers as well. Why did we fine-tune a model? In order to use it, right? So fine-tuners, they need to have all the capabilities of consumers that we said earlier. So they need then to start playing with prompt engineering and to do all the different stuff that we saw earlier. And lastly, we need to continuously monitoring the performance of our fine-tuned models in order to know when we need to create more labeled data or to parameterize differently the training job for the fine-tuning in order to improve continuously our models. And this is the life cycle that the fine-tuners they used to use. Now, what is fine-tuning? This is the most important thing, right? We talk about fine-tuning, but what is that? We have two types of fine-tuning. We have the full fine-tuning, right? The complete fine-tuning, that actually what is happening for all of you that you are familiar with this. We go and we recalculate all the weights and biases, the different billions of parameters for the model based on our own data. As you can imagine, this is a computational intensive process that requires also a big machine, a big instance with multiple GPUs. So what the researchers did was to have introduced this parameter-efficient fine-tuning. What is this parameter-efficient fine-tuning, or PEFT, right? If you have heard about LoRa, LoRaQ, and all these kind of things, this is the domain. So instead of going and recalculating this massive model, what you can go and do is you can go and add layers or specific adapters to this model. With that way, these new adapters allows the model to perform a new task. This might be a question and answer for financial or summarization or something like this. That means that you don't need to build continuously new or fine-tune continuously new models and deploy new models. You can have one large LLM or foundation model, and then to have multiple adapters for all your different tasks. This will reduce later on the cost massively. Why? Because originally what you need to have is multiple servers with GPU instances, one server, one model. Now you can have one model, multiple tasks under the same server. So with that way, in AWS, we help you to reduce the cost massively by having one model and multiple tasks. And you will see more in this domain coming in the next few months. Okay, now, in this domain of fine-tuning, right, and data science, the word that you will listen a lot or hear a lot from AWS is SageMaker. I love SageMaker. I use that for the 5 last years now. SageMaker is the umbrella of tools for data scientists. It allows you to go and browse more than 730 models in Jumpstart. That at 1 o'clock we have also a demo and a workshop to show you how it looks like. So you have access to all the Hugging Face models or Llama models, Mistral, so you are able to play with any open source model you prefer. We have capability, so SageMaker Jumpstart is the catalog of all the models. SageMaker Clarify is the service that we allow you to do evaluation in depth, as I said earlier, about toxicity, semantic robustness, embedding of the tasks that you have. So we provide to you the code or the tools to produce all these algorithms, and we have different approaches, either through the UI or through APIs. We have SageMaker Training that helps you to fine-tune your models, and you can train massively any kind of models you prefer. And we have SageMaker Inference that you can deploy the model in an instance or server differently and can start getting requests and return results back. Now, in this deployment also, we support different other functionalities like optimization of the cost, optimization of the latency, so you can have full granularity about the control or customization that you want to do in your models. But this is just pillar one. This is what you can do currently on SageMaker by using the UI even, right? But we have also some capabilities that you can use the API in order to perform those. These two capabilities are related to experimentation, LLM experimentation. This will come soon, right? You might want to run multiple experiments with multiple models, multiple configuration, etc. And to wrap all this process under an automated workflow, we call it pipeline most of the times, in order with a simple click to do the evaluation for a new use case that you might have. So the data scientists, they don't need to go from scratch, click, 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 but they have an automation to feed it and give the right answers for them. And here is where we have MLOps, of course. In SageMaker Jumpstart, just to give you an overview, these are all the different families of models that we support. That's why we have 730 different models available there. You can play with all of them. You can select which one is the best for you. I have seen a trend in the market that smaller models, they come into the game. Why? Because we need to reduce the cost massively. We need to host the model inside a mobile device, etc. So you have the option to play with all of them. Now, in addition, go back. In addition also to the different models that we provide to you, we provide also different options for hardware, right? You have heard continuously that these big models, they require GPU instances, GPU machines, etc. So what AWS said, we will build our own hardware in order to make all the processes faster and in order to reduce the cost for our customers. So we have AWS Trainium that can help you to train, fine-tune your own models. And we have AWS Inferentia that you can deploy your model into this chip, and you can reduce massively the cost by 40% or so. So we don't support just the tools, we don't support just the APIs, we don't support just the UI, but we give you also the hardware if you want to go in that. I will open a small parenthesis about MLOps because it is very, very, very important to be in the same page, right? Because mostly the fine-tuners or the producers later on, they need to implement MLOps. So you need to know about this. MLOps is the combination, again, people, process, and technologies. We used to say that again and again. Why? Because you might have the best tools, you might have the best car. If you don't know how to drive it, probably you waste the car, right? So, and MLOps is how you can do that efficiently to productionize models. And the key KPIs that we give for MLOps is speed to value, right? We want to bring more machine learning models into production faster. We have seen customers that they spend 12 months to bring one ML use case into production. We show them how to do that in less than 3 months. We see customers that they already have a solution and they don't know how to productionize. They spend months and months. We can show how you can do that in less than 2 weeks. Of course, in a very secure manner, without internet access if it is required, with all your data secured, with everyone to be happy. I have a financial customer that within 1 year, they developed 170 ML use cases and they moved that into production. And they are extremely happy and they make revenue for them. So overall, from an MLOps platform, what we are trying to do is to reduce the platform, people, and technology cost and operation cost. Something similar is what we are planning to introduce to you in the market about the LLMOps platform or the FMOps platform or GenAIOps. These are the 3 key terms that we have seen in the market. And just to give you also to understand how all the different teams and what are the different personas. Might be one person that has 2 hats here, but anyways, to show you the puzzle and how to operate on the cloud. We have the platform team most of the times on the cloud, that we have the solution architects, the system engineers, that they create AWS accounts, they create users, they link the right users to the right accounts. Then we have the data layer. The data layer is the place that we have the data engineers, that they ingest data to the cloud, they pre-process the data, they store the data, they catalog the data, and the data owners who are responsible to share this clean data with others. And we have also business owners to check the data through visualization dashboards. So up to this point, this is very, very important layers that you need in any GenAI application, right? But when we talk about fine-tuning and data scientists, we need to have also a place to allow them to play and break. This is the experimentation environment. In the experimentation environment, we have data scientists that they can experiment with different models, and then it is the MLOps part that begins, and we have an environment to build the models with a very robust way, with automation, and we have data scientists and ML engineers collaborating together to build those, and we have 2 isolated environments for model testing and model deployment. And the last piece of the puzzle, at the top, if it will come, is the ML governance. ML governance is very important. It is a place that all the owners, they need to have all the models that they have produced to assess, to benchmark, to see what is going on with the performance of the models. You need to have the approvers to say which model will go to production, and you need to have the auditors, they need to have access to this environment in order to check what model you use, what artifacts, and what data in order to produce the particular model. This is very important for financial sector. Now, the last piece of the puzzle, after we have built all this, before that. So, I talked about MLOps. And earlier I talked also about the notion of FMOps. What are the differences between the 2? MLOps is to productionize machine learning models. FMOps is to productionize foundation models. And a subcategory of FMOps is the LLMOps. LLMOps is to productionize large language models. Okay? The key differences again for this one are, finally, so the key differences, people and processes, as we already examined, how to select the right model, right? You are not going to fine-tune all the models in the market. You need to select the right models for you. You need to be able to evaluate the model with a different way in that classic ML. You need to fine-tune models, train with a particular way. You need to be able to understand how to shape the data. By the way, how you pre-process the data is a very difficult task, and we can talk that offline. And all this lands to technology. How you can extend your cloud platform in order to host all these capabilities. And then this puzzle box here, what will happen is it will be extended. If the team can help me to click the button. Perfect. You will extend that with the application layer at the bottom. The application layer is the place that we write, we build all these boxes that I showed you earlier about the GenAI application that has access to the data, that has access to my production environment to call my models. And more or less, we have these end users to interact with this GenAI application that we have built. This is an enterprise-level landscape that most of the very big customers they used to build. Now, depending on your maturity, depending on your size, this might be smaller, less people doing multiple jobs. Okay? And because I'm a technical leader here, right? I like some service architecture designs. I said to have the last slide in this fine-tuning world with some architecture stuff. So, normally, to fully automate the whole life cycle that I showed you earlier with all the different steps, what you need to do is, first of all, you need to create these pipelines, as we call them, to do what? I have one use case. I had 3 foundation models that I told you earlier. I want to fine-tune one of them, and I want to evaluate all of them. And I need somehow to have a selection step. So this automation with a click of a button, what we'll do is we'll do all the different processes that I said earlier for you automatically. And by the end of the day, the best model will be moved somewhere that we call it model registry. Model registry is a place that we store all the metadata for all the models, what containers you want to use, etc. So it is the single point of truth of your models. And version 1 of this particular, let's say, run, the first run, might be Llama 2. The version 2 of a model might be Bedrock. Version 3 might be Llama 4, etc. So now I have my model in model registry. So I need someone to go and approve the model to go to production. Yes, version 2 should go to production. We have the approvers that they approve the version of the model. And then we deploy that into an endpoint. An endpoint is a server that we host our model. Over there, we need to do continuously monitoring, right? We need to check all the interaction, everything. And for example, if I have a model that produces toxic solutions, toxic answers continuously, I need to re-execute this pipeline. But if I re-execute this pipeline with the same data, this will give me the same results, right? So it does not make sense. So what I need to do is I need to get from the monitoring the bad records, add them into my original data, and re-execute the pipeline with new, fresh data, augmented data based on the bad cases in order to select another or the same model, depends on the scenario. Another reason to re-execute this pipeline is if a new version of the model appears in the market, right? I have Llama 2, oh, Llama 4 is there. Let's add it there, and let's execute the evaluation only for this model. And we have then users interact through an API with the model. We need to have a layer of preparation of the prompt. The prompt that an end user will give us a question, right? What is my XYZ? The model might not be able to understand this. You need to translate this prompt to the right format. And you need also to apply all the guardrails that I said earlier about filtering of inputs, outputs, etc. This is the layer to do that. And then the last piece is we need to continuously improve our solution based on the rating, based on the feedback that the end users they use to provide. So more or less what we need to do is to get this feedback from the end user, translate that, add this feedback, the new records into my catalog, and then I'm able to have a proper evaluation next time that I will do something. This is now the end-to-end LLMOps lifecycle and how someone can productionize an LLM model that they want either to deploy on the cloud or fine-tune and then deploy there. The last journey that I know that most of you are not there, but is good to know, is about providers. The providers, they need either to label massive data or to prepare massive data. Then to create a foundation model, we have customers that they spend weeks to months to train just a single model, right? And the outcome of this is to deploy also the model. And then we have different leaderboards in the market, like Helm, etc., that they go and assess the performance of the model. I'm not quite let's say, supportive of the leaderboards because someone might have optimized a model based on the leaderboard, right? So I suggest to evaluate a model based on your own use cases. Now, what is happening is, if, let's say, this process takes months and weeks, right? How can we make sure that the hardware does not go down? The hardware is error prone, right? Something might happen within 1 month and to lose everything. So what AWS said is we will help these providers that they build their own foundation models with SageMaker Hyperpod. SageMaker Hyperpod is nothing else than a cluster of machines that they can run this training and to build their own models. It makes sure that if hardware fails, it replaces that and the training continues as normal. So the users, they don't lose any information, anything. It supports checkpoints. That means that we store all the different stages of the training so they can resume even the training. And more or less, to make it simple, we make sure that the training will be completed successfully and whatever you paid is whatever you will get as well. And we have, as an example, our friends here from Hugging Face for Stability AI and Perplexity. All of them, they're using Hyperpod to build their own models on the cloud. And with that, and with this amazing clicker, we will go to conclusion and some resources for you. What we saw so far is we have the consumers, right? That they want to use just applications that their applications, they leverage generative AI. We have then advanced consumers that they want to explore the LLMs, they want to use APIs to call them, etc. And finally, what we have is the layer of the more advanced users or fine-tuners and providers that they want to have full control of their models. This is the stack that we have seen in the market and what we propose. And here are all the different products that you can use in all the different cases. So what I suggest is understand where you are in this journey and try to play with the corresponding tools that are available on AWS to make generative AI a reality. And for you, I have prepared, before the thank you, I have prepared a list of references that you can check about LMOps, FMOps, the third one. The two first is about Bedrock and SageMaker. And the last one is one workshop that we released recently around SageMaker and shows you end-to-end how to perform everything if you are a data science or ML engineer like a story. So you will be able to use all the different tools to see how everything is linked together. And this is what we will show you with my colleague Nikiforos at one in the demo that we will give. With that, thank you very much. If you want to link with me, connect in LinkedIn. I upload videos to YouTube for everyone because I do all those presentations again and again, and I want to share the knowledge with everyone, right? In order to have success stories. Thank you again.